Hello and welcome to the FMCC webinar, Smart Cities and the Effect on Facility Management, presented by Paul Doherty. Next slide, please. I do want to let everyone know they have been muted for audio quality. If at any time you do have any questions during this webinar, please feel free and type them into the question box on your control panel, and we'll be happy to go over them during the Q&A portion at the end of the webinar. Also, a recording of this webinar will be posted to the FMCC website in the coming weeks, so be sure if you want to check it out, or if you enjoy it so much, Paul does a great job, go ahead and send that link out to other people. Also, if you want a PDF of this PowerPoint, feel free to download a copy in the handout section on your control panel. Next slide, please. The FMCC does want to let you be aware of their vision and mission statement, their guiding purpose. Thank you. Next slide. And the FMCC does provide many services to the FM community, such as Ask the Expert, Find a Consultant, Locate a Speaker, and online educational resources. You may find more information on their website, fmcc.ifma.org. Next slide, please. And as always, we want to thank our sponsors. Next slide. And the reason we're all here together today is World FM Day, which we have actually kind of morphed it into World FM Week. So we're so thrilled to celebrate FM around the world and bring attention to this great profession. Next slide, please. And so in honor of that, the FMCC has put together over 30 sessions that were started on Monday and are going through tomorrow. So next slide, please. I encourage you to continue to sign up for some webinars, and we would be thrilled to see you. At this time, I'm going to go ahead and turn it over to our presenter, Paul Doherty. Paul, the floor is yours.
Thank you very much, Joshua, and welcome to all the attendees to this webinar. Right now in Central Time, U.S., it's a good evening, and for those of you in Asia, good morning. My name is Paul Doherty. I'm an architect. I actually have founded and I am a partner in TDG, or what's known as the Digit Group. Just to give you a little bit of background to let you know where we're coming from for the next hour, is that we are real estate developers that help owners, mostly municipalities and government agencies, realize the potential of their urban environments from a safety, security, and a better user experience methodology. A lot of that does not really directly involve just technology. When you hear the word smart cities, it's about process, it's about behavior change, it's about how does the facility management profession start to realize the importance of the value of what they do day in and day out and how that integrates into the urban fabric, as 85% of the world's population in the next 35 years will be in urban environments. So this is no longer about the contextualization of what you do in your one building, but rather, what is the contribution that your building or buildings are going to make because of the digital DNA that is part of your responsibility of documentation, of day in, day out operations, of understanding how building management and building automation systems can now start to talk with other things rather than just the building itself. So that's the overall idea. We are, what we perform, which you're going to see examples over the next hour, is really about this idea of government relationships and how important those are becoming, where the communications between the governed and the governors are decreasing every day, mostly through social media, but also through programs. And how do you start to interact with them? Because what we're looking at right now, some of the largest projects in the world be going not just onto the budgets of large-scale or small-scale governments, but what we're finding is that they are looking for partnerships. And this becomes really interesting in the world both of Fortune 500 facility managers all the way down to the sole practitioner, because we are now looking at the art of the possible. We are actually moving into a world where we have the ability now to make a big difference. The shackles of the past, especially with our understanding of the limitations of information technology, is also now giving way to this world of data. And that's really where we're going to be focused in today, is the world of data, making it pragmatic so that tomorrow morning you can actually make some practical decisions about starting to learn more about this idea of smart cities and how that's going to affect the facility management profession. Just some other notes here. A lot of the projects you're going to see were introduced to us as a small medium enterprise through the Obama administration and the Office of Science and Technology at the White House. They were wonderful. The federal government was wonderful and still is actually today with the different departments from the Department of Energy, Department of Commerce, Department of Transportation, and the State Department in assisting these big ideas of what does it mean to have a high-performance urban environment, and how, in the case of the United States government, how do we start promoting things like the the world of American goods and services. But what we find as an interesting after effect is working with organizations like the central government in Beijing, with President Xi and Premier Li, working with the Australian government, Prime Minister Turnbull down in Canberra, Prime Minister English over in New Zealand in the city of Wellington, and then our extensive work now with the Kingdom of Saudi Arabia, working directly with Deputy Crown Prince Salman and with Sheikh Mohammed in Dubai in the UAE. The reason why I'm mentioning those names is because the projects you're going to see are the ones that you're reading about in the paper, and this no longer gets to be just the world of the big boys. This is really about bringing together a lot of different folks that can do some pretty amazing things together. So with that in mind, the learning objectives of the next 50 minutes or so is to construct a solution framework. In other words, what are the best practices out there for your organization? How does that really affect you? Also identifying these emerging technologies, because once you identify them, the standards and the processes for your organization become the implementation mechanism for that. The other thing is also to understand the effects of culture and technology into the processes. I think that that's going to be probably the biggest thing, is the human factor, the growth factor of that. And then, of course, how to implement these tools and services that provide practical and probably most important thing, measured success. So with that, let's talk about the art of the possible. It used to be that the limitations of information technology, of communications technologies, and of processes were really about the individual's use and skill sets associated with technology. A case in point would be like an architect. Most architecture that I see today is aesthetically, sometimes it can be interesting. The majority of it's horrible, and that's not just an opinion. You can actually see it in the way that architecture has moved forward across time, where since the introduction of CAD and now BIM, the limitations of the user is now starting to limit the actual creativeness of material sciences, of really starting to understand how the building itself can be pulled up out of the ground in an interesting way that lifts the human spirit. That's what we'd love to say. What we're finding, though, is that people are limited because of their lack of understanding their tools of creativity, the actual design tools themselves. So how do we move beyond that? And what we're finding now is that through the use of the internet and then the actual services within the internet, meaning, I'm sure you've heard the word the cloud, that is where we have computing power that we've never been able to afford before, nor been able to access before. So that's where we have a huge difference of the past generation's use of IT and this generation's use of IT. By leveraging the cloud and all of its power, we're able to make better decisions and also now free up how programs and applications and apps, which are like mini applications, I'm sure many people know this from your use of mobile phone apps, just that alone is starting to make it easier for people to express themselves, to be able to work better, to get better informed, better data so that you can make a more informed decision. This is the art of the possible. And what we're finding right now is that when you start to put that thinking, that definition of thought, what we're entering right now is this world of smart cities, where we have innovative high-performance environments based upon 10 guiding principles. And you can see this particular slide, we have energy and water, and waste, and education, healthcare, citizen services, green sustainable buildings, public safety and security, transportation, and a term called ICT, information communications technology. There's a perfect storm that is happening right now because of the migration of humans into these urban environments. The clustering, the density out there in certain areas of the world is actually choking certain services and infrastructure in some of these cities. So how do we, as the stewards of the built environment, the people that are actually managing and operating these buildings, What's our contribution? How is that going to affect us? And what we're finding is that by understanding that the geopolitics sometimes that are involved, like in the case of China, you have a little over 300 million people migrating today. So that's just a little underneath the entire population of the United States moving from an agricultural Western province, culture and society into the modern world of the East Coast cities of, the Shanghais and the Beijings and the Guangzhous and Hong Kongs. There's a huge issue there because culturally, these cities are already overpopulated and now they have a crush of humanity coming to them because they're looking for jobs. The reason why these people are migrating is because they have mechanized their food supply chain and created safety and security measures for that food supply chain that they're able to feed themselves, which means that when they mechanize, they don't need as many farmers. So what do? So this becomes a big deal, in the speed to market that you're hearing, specifically in the place of the People's Republic of China, where they're doing smart cities not because it's, the next evolution or it's something cool or they're trying to attract people to their cities. What they're doing it is for pragmatic purposes, for survival. They have built many cities that are very traditional. I'd say right now I know of 20 of them, 16 of them are empty. And these were meant to be buffer cities, where they built them out in areas like in Wuhan and central China and whatnot in order to absorb this crush of humanity coming to the East Coast. Well, these people walked right through them because they forgot one important thing. You have to have a soul and you have to have a reason for having a congregation of people in such a dense environment like an urban environment, and you have to allow them to fall in love with a piece of dirt. And they didn't do that. They built up things that, as they thought they should, school, hospital, police station, fire station, government offices, and let's say not the most pleasant looking high-rise residential buildings. But they forgot about, the actual urban fabric, the things of like parklands, being able to explore things, being able to have the ability to, make it their own. And that's a huge lesson for the world of smart cities because although there will be less amount of new cities coming up over the past, over the next 50 to 100 years, they're still going to be there, and that's my job. What I'm learning, though, is how do these hybrids work? How do you start to create neighborhoods that can then start to grow and, sort of become the next generation of an urban experience? And that's where this operative word comes in, innovations. Innovations can be in the form of information technology. They can also be in the form of hardware, and certain cases they can also be in the form of behavior change. So what I'm going to show you is how you should be thinking as a framework about when you start hearing about smart buildings and smart cities, that we should also be thinking about built-in obsolescence, because the innovation now is going to be a never-ending stream, like a spring well of ideas that will never stop. So our job as the facility management and the stewards of the built environment is to rethink when we make a decision, and then start to take a look at innovations not as a singular entity, but as part of an ecosystem. And so the first one I want to show you is called piezoelectric. This is a technology born out of the Kinetic Energy Labs at Georgia Tech Research Institute, or GTRI. This particular technology takes certain materials and puts it as a substrate underneath finished floors. So things like carpet, wood flooring, ceramic tile, for the interior, for the exterior, things like rubber, asphalt, concrete, things like that. So what's interesting about this is that the materials used underneath those surfaces, when they're compressed, they excite the molecules, which then generates energy. That energy is collected and harvested through a graphene battery that's about 1 millimeter thin, which then can be discharged either through a distribution system, through wireless charging, like Qualcomm's Halo being one example, to laser beams, tiny lasers that will actually send the electricity where it's needed. Imagine shooting electricity, from point to point as part of a quote-unquote Internet of Things way of working. What's really cool about working with the piezoelectric systems is that we're just scratching the surface in our understanding of its real power. no pun intended. But the energy created there will increase over time as the different materials become more mature and the installations become more prevalent. Right now, the price per kilowatt hour is about at the equivalent of an installed solar system, solar energy system. So, relatively not cheap, but also not too expensive. What we are looking at, because of the installation and the productization of the piezoelectric products, in different forms and different formats, over the next 36 months, we're probably looking at the same price point for energy collection, energy harvesting, energy distribution as coal, so fossil fuels. So that's a very short timeline for this to come online. But let me show you, what I'm talking about here. What you're going to see is, what you see here are images captured from 3 specific places where it's been installed. On the left-hand side, the energy generation, storage, and distribution is actually Atlanta Hartsfield Airport. What you're seeing here is the mock-up of a piezo selfie station, so that if you're standing online at the TSA main area to get into, through security at Atlanta Hartsfield Airport, you will see one of these stations. You can go up to it and dance on the interface carpet, which has piezo underneath it. And what happens is the more that you move, the quicker the LED lights up on the stanchions light up. Once it gets up to power that particular camera, it takes a picture of you, and then it's up to you to put it up to your Instagram or Facebook social media page. So that's just a behavior change way of looking at piezo to get people introduced to it. Up in the right-hand corner is a piezoelectric installation that was just completed at the Kennedy Space Center Visitors Center at Cape Canaveral on behalf of NASA. We're calling it Piezo Universe because we have installed a translucent finish that allows people to learn what piezo is all about. So as you step on it, it lights up, and then you can see how we've routed the energy to light up the lights, to maybe just educate, maybe jump from one piezo tile to another. It depends on how you want to experience it. The third one is an installation that is soon to happen, which is at the new Mercedes-Benz Arena, Mercedes-Benz Stadium in Atlanta. What we are looking at right now is an installation on the concourse for everything from food and beverages to where's the bathroom. And that movement of people will be generating power that should keep the equipment and appliances going throughout a game. The Atlanta Falcons will open up the season here, and the NFL was right now considering putting the piezoelectric into the actual field itself, so that as the Atlanta Falcons play a game, they're actually lighting the lights that you're watching the game from. So these are just some of the pilots that we're going through. We do have big plans, of course, for our smart cities, both for interior and exterior use. Now, as a standalone innovation, piezoelectric's pretty cool, but what else can you do with it? And this is where we have this world of transportation. Right now, my video is not working because of the GoToMeeting limitation, so I apologize. But what you can see on the right-hand side is the idea where you have 2-meter buses, for all intents and purposes, almost like the size of like a mini car. It fits about 8 to 10 people, depending on the configuration. This has been sold to the municipality of Dubai. They purchased 100 of these, and we're partnered up with a group called Kareem, which is like the Uber of the Middle East. The RTA is the actual vendor. The RTA stands for the Road Transportation Authority of Dubai. And what we're doing is we're doing pilot tests for the next 2 years in order to have 3,500 of these things be able to be the main transportation system for the World Expo 2020, which will be held in Dubai. Now, how this works is that each 2-meter bus, when you hail it, like let's say through Kareem, it comes to pick you up at the point of where you've requested it. So you really don't need to have bus stations and stuff like that, and bus shelters, because it's where you want to be picked up, like Uber, right? At the same time, when you get into the vehicle itself, other vehicles may then attach itself to you, because the vehicle that picked you up may not be the one that leaves you off, because what they're trying to find are areas that people can be picked up, pushed together, and then move into another vehicle so that vehicle peels off and actually brings you and the other people that are close to you to your actual destination. Now, the reason why this is important as well is that we are looking at incorporating this as part of the metro system, which is an above-ground monorail system that runs throughout Dubai. This is actually the last mile to keep people air-conditioned, right? Because once you're in the metro, that's fine. But the thing is, how do you then keep people air-conditioned and cool in order to get to their destination where they can get out and then go back into air conditioning again, right? So it's trying to create that continuity of comfort all the way through. The other interesting thing about this type of transportation system is that this is not just for transport. Excuse me. This is also used where instead of, like, let's say you use one of these centipedes on the way to work, and you want to get a coffee, maybe over to Starbucks. Instead of going to the Starbucks, you can actually use the app that you use to hail the centipede and then have the Starbucks pod connect to you to deliver your latte. So goods and services is really the main thrust of this particular transportation system. And we can actually attach upwards of 10 of these together. You know, that's a pretty long bus, if you want to call it that. So it's actually a new form of taking transportation to the next level, of combining the flexibility of Uber along with the you know, the ability for you know, a bus type of routing system meeting a train methodology. So this is something that we feel is one individual transportation or innovation will fundamentally change the shape of our master planning of our cities. 120 years ago, there was a brand new innovation called an elevator that fundamentally changed the shape of cities because you could go tall, vertical, right? What we're looking at now with these, you know, with these centipedes is that our roads are more narrow because they're all autonomous. There's no need for stop signs or traffic lights, and most importantly, there's no need for parking lots. Now, the other thing that's not needed are charging stations. Because of the work that we're doing right now with a tire company, we are looking at the material sciences of piezo, of lining the interior part of the tube of the tire to be piezo enabled. So in other words, as you're driving the compression, you're already creating power, which means that we are figuring out through a number of different really cool innovations how that power then gets transmitted into the actual unit itself, the actual vehicle. And then ultimately, if you have excess energy, wouldn't it be interesting that maybe there are stops, like the metro stops, where a lot of these centipedes are going to be, that we can then either laser or through Halo wirelessly send a charge into the actual structure itself of the bus so that we can do one really important thing, sell electricity back to the grid. Because now we have a really, really interesting ecosystem, right? We have the first thing, the piezoelectric. It could be in the road. It could be in the tires. We're now bringing in a new transportation system that's fundamentally changing the shape of the city because you no longer need to have a grid. So much more interesting ways of exploring the contextualization of topography, of climate, of what makes up the uniqueness of every city in the world, and exploit that to a strength, right? Which leads us to the you know, to a third technology. Again, the video is not running on this, but that's all right. The transportation part of this for traditional buses is also changing, where we have branded autonomous electric buses. This is one that we have called the Next Gen bus. These are EV and AV LED buses, meaning that these are translucent buses, right? Now, why is that important? Well, for a couple of things. Number one, we're trying to make this free for all users inside of a smart urban environment. And if you have, you know, the ability to download an app, that's how you're allowed onto the bus. On your app, though, are going to be just certain personal information like your first name, your age range, and maybe your male or female. And those data points are enough for advertisers to start to aggregate that information so they know who's on that bus. You know, what's the average age, what's the average, you know, likes, dislikes, all that type of stuff, so that they can actually then have auctions in real time beaming down onto the bus so that, you know, as the ridership changes on the bus, the exterior becomes a different way of having different types of advertisers that are target marketing that particular demographic. that becomes really, 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 really important because that's a non-tax-based revenue stream for the municipality and free public transportation and hopefully something that's safer than what we have today because of the autonomous nature of this. So again, this 12-meter bus is something that is learning from the 2-meter bus because of the autonomous technologies. The autonomous technologies that we use are not collision-free because we want, in the case of the centipedes, we want them to collide, albeit in a controlled way so that they could connect. But it's a much different type of way of thinking about the software that's running these autonomous vehicles around the world, where right now we know that Apple is working on it, Tesla, Intel just bought Mobileye out of Israel, which is also an anti-collision piece of software. So everyone's thinking anti-collision, and we're thinking already 2.0. So a very, very interesting time when it comes to who's going to win, because one thing you don't want to have as a facility manager or as a citizen is like, let's say you work in San Francisco and you want to drive to Oakland. San Francisco has taken Tesla as their autonomous software base, and maybe Oakland has taken Intel. Who wins? You have two different operating systems. It means someone's going to have to reboot their car every time that you go from jurisdiction to jurisdiction. I don't think anyone wants that, which is why, working right now with DOT in Washington, along with, organizations like Homeland Security, FEMA, and others, we are looking at taking a lead and involving NIST, the National Institute of Standards and Testing, to take a look at the autonomous nature of not balkanizing this thing because you'd have a stillbirth on the technology. So as the same methodology as the centipede, our next-gen bus will also have in the tires piezoelectric so that there is no need for charging stations. We also are placing it in the slow lanes where the buses are going to be driving so that there's a continuous charge either through cars that are in the bus lane and or through the buses themselves rolling over this. And of course, as you come up to the bus shelter itself, that's the opportunity to sell the electricity that you're not using from point to point on the route into the grid for, yet again, another revenue stream. So these are what we're talking about, these ecosystems. We have transportation, we have energy. Where else are we going with this? Well, there's a technology that has lately been developed that plays on the entire idea of privatized wireless communication. And what I mean by that is that when you have Wi-Fi, the physical nature of Wi-Fi means that it has a spread spectrum, meaning that it goes out horizontally, which means that you're trying to connect things, which is great. It also means that you can hop from one point to another point horizontally, and you wouldn't know that another person's trying to like hack you, let's say, right? And that's always the danger of things like the internet and spread spectrum, is that everything's horizontal. Wi-Fi is like a vertical version of that, so that you're not bleeding into like the next office with your email, or the potential of intercepting, a text message, that type of thing. Because it goes north-south, it means that you almost have like a cone of information. And how it actually operates is actually through LED light spectrums. In other words, the reflective nature of LED puts out a certain spectrum that Internet Protocol can run on top of, which is pretty spectacular. Because when you have light that's transmitting, you can get a very, very efficient throughput for that telecommunication, so much so that we're calling it Li-Fi, that uses LED emittent light to drive internet access in a safe way at upwards of 10G speeds, 10 gig speeds. So that's more than double than what we have today. It's a fantastic new way of looking at things. Now, how come this is part of the ecosystem? Well, all the lights in our smart cities, instead of using HID type of lights for our street lamps, are using LED, which means that we can run 10G from light to light pole in order to then have a total free 10G Wi-Fi network throughout the city that's secure. So just think about that. We have power, we have telecommunications, and we have transportation, all working as one unit, as an organism. And that's probably the biggest thing that I'd love to have you take away from this hour-long session, is that we're no longer in the world of trying to control nature as mankind. You know, ever since, you know, the son came, Louis XIV in France, you know, trying to take control of his gardens and through architecture and outdoor sculpture, which was nice, all the way through today, you know, of the way that we mine things and fracking, just all this stuff. Economically, I understand it all. You know, morally and ethically, that's an opinion. But what we're doing is actually making more problems for ourselves than we need to, because we think we can control nature. And that's one of the things that I think that, you know, the generations that are coming up, if we can leave behind any sort of legacy, is this. Buildings are not a machine. We're treating them like a machine. We almost have, you know, the idea of a boiler as an engine, you know, going down there mechanically, we got to make things work. We still have to consider that, and we're getting better at it. You know, this whole notion of green and sustainability and whatever people want to call it, I just call that good design. When I went to architectural school, that's what it was. We didn't have to celebrate it. So let's not celebrate, just do something about it, which means that we're looking at buildings as part of an organism. Buildings as part of an organism, which allows us now to take into account these innovations and integrate them seamlessly, not just for the building themselves. The big deal of smart cities is the space between the buildings is very, very valuable. So that's another takeaway. It's not just the building itself. You're supposed to take care of your building. That's why we have organizations like IFMA. That's why we have training programs and all this other stuff in order to get better with your skill sets to make sure that your building is at its optimal best. The key, though, is that that's not enough. If your building is part of an organism, we've got to start reaching out with data, you know, of course, securely, and start to define what the experience is when you're in the building, when you're coming up to the building, when you're leaving the building. And now we start to take that into context of the overall management of the city, that if every building is defining corridors, things like streetscapes and whatnot, and that we have the Internet of Things sensors doing all sorts of things for safety, security, ease of access to the internet, all these things that the larger technology companies are throwing at us, we now have the contextualization at our, you know, at our beck and call. And that's the big part that I think as we start to take a look at, well, how do we do that? We have to take a fresh look at what we ask our consultants, our architects and engineers, that when we are doing a tenant fit out or a new capital project like a building, we should be asking for things that we know we're going to be doing something with. Up until now, there's been a lot of talk about building information modeling. And a lot of people get caught up on it that it's like a 3D drafting tool. That's the least of its value. What it is a model of data. And because it's a model of data, we can actually now start to dictate what we want from our consultants. We don't need an entire Revit model. We need certain pieces of data in that Revit model to be authenticated and trusted. Maybe, how about its location? Because after all of us get as-builts perfectly every project, right? No, we don't. That's because we have a fudge factor called human beings and human behavior. The actual data itself resides somewhere. It's about the QA/QC process and how we start moving forward and what we're asking for, which is where we start getting into this idea of having, you know, no longer just architects and engineers, but almost like a new type of professional that we're seeing emerge very quickly with the younger generation that are taking to tools like BIM, like virtual reality and augmented reality, and mixed reality like Microsoft's HoloLens. Why are these things important? Well, because they define a process much differently than the silos of what our consultants work in. You know, an architect is an architect, structural engineer, MEP engineers, blah, 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 blah. The thing is, when you try and put all their information into a single model, it doesn't work. And the reason why is because, you know, when we were designing Revit, I was part of a team that was part of the original, you know, team that created Revit, the first, you know, large-scale building information modeling tool. And when we sold it to Autodesk, we really had built it in mind for a new type of professional called a virtual design and construction professional. The VDC world is maturing very quickly, but where we're finding it from is actually from the world of the trades, specifically the union trades in the United States. I had the fortunate experience of going to a training center for a union local for the pipe fitters union in South Chicago. I forget the exact number, 823 or 829 or 283. Anyway, bottom line is a local down there, and they have this huge training facility. And really what it comes down to is they're teaching apprentices how to measure twice and cut once. I mean, that's it, right? Now, the skill sets involved with that, with the different types of pipes, the different types of tin knockers, the boilers they have to deal with, all this stuff, that's where the skills come in, right? So what they've done is that they've taken virtual reality and actually given out the gear to individuals to put on their face, and they run through exercises. When I first walked in, there was a group of 10 of these guys with these virtual reality gear goggles on, and I thought that I was looking at like another version of like Tai Chi, right? Because they're all moving and they're all like doing things with their hands and whatnot. And the way that the superintendent told me, he said, yeah, they're learning how to get in the pipe. In other words, the ramifications of how they're cutting with what type of tool, the types of material of the pipe and everything. They can get down to the molecular level of virtual reality to really understand what the hell they're doing. They can actually then grow out to be gargantuan guy and look at from a high viewpoint the overall effects of what they're doing. Be it on a site that's really tight to an existing boiler that needs to be fixed to and the piping involved all the way through new installation and new construction. What I learned there though is that the trades, when they start to learn how to do it in a VR way, they're using BIM. They're actually using Revit models to move through it. And the reason why is because Revit, although it's horrible with graphics, I mean, it makes everything look like a cartoon. But what it's really good at is geospatial information. In other words, you can really scale that, that's a 10-foot opening, and by God, it's a 10-foot opening. No matter what scale you look at it in, like if you're really small or really, really big, it will always keep its scale. It's very good like that. So that's why we're looking at, at BIM 2.0 being such a valuable tool. Because here's the secondary account. So we have the trades that are redefining how means and methods get put into the model so that you can actually say, yeah, this is a realistic model. The second big idea that comes out of this is we can lock down through a QA/QC process, so quality assurance, quality control process, exactly where that VAV box is up in the plenum. No longer are you going to have your guys take out a ladder, pump up through the hung ceiling to see if the VAV box is actually there. You are going to be able to trust that, and it will be authenticated. This QA/QC process is something that has only really started to take off over the past 3 years or so through the maturation of tools out there like Celibri, BIM Assure, and others. We have now the ability to take care of all those primary points of data and have them trusted in a virtual representation of that building inside of a geospatially perfect environment called a gaming engine. This means that that VAV box in the virtual space is exactly at that latitude and longitude at that positive Z axis, and you can count on it. Now, when your building can then start to publish that it has trusted data, like let's say your mechanical systems, your electric systems, your plumbing systems, your structural systems, your safety and security systems, you now have trusted data. You are now a bank. You're a data escrow bank. And your building can now communicate with other buildings with other trusted information. When you start to connect those two pieces of trusted data, you are now creating the environment for transactions. This is the same methodology, the same IT, the same process that has created a brand new currency that's taking off like wildfire called Bitcoin, digital currency. We're looking at it from the facility management aspect that when you have one-to-many or one-to-one communications of physical buildings that you're going to be able to control through a cyber or a virtual world for transactions of things like load shedding of energy, water sharing, security, safety, all of these different things. We are entering a new age of facility management that we could have only dreamed before. Because now all of a sudden your buildings can communicate with other buildings to create corridors of safety, corridors of security so that it can make decisions quicker if there's an incident faster than a human being can and actually respond to it before the first responders are there. There's technologies already out there like, Shot Spotter out of Oakland that is using microphones in high crime areas to alert authorities that are then called to, like, let's say an intersection of where shots came from, at least directionally. Now with the world of BIM, we can also say it's just not the northwest corner where the shot came from, it was up on the 3rd floor in this room, right? So again, one very simple example of where BIM with true as-builts, as you trust the data points and have those data points communicate with other buildings, you're now creating the Internet of Buildings. This is the new age of facility management. It's something that I think is one of the most exciting opportunities for the facility management profession because of the sheer blankness of the canvas, because we haven't discovered what we don't know yet. Yet we're looking at lockdown, lockout procedures now, helping authorities capture perpetrators in ways that human beings can't react fast enough. Here's a case in point. Let's say ShotSpotter identifies that there was a shot fired. Suddenly the CCTV cameras between the different buildings are all now locked into finding the image of that person. They find them. Building number 1 says to building number 4, hey, building number 4, the guy's coming towards you. You have a vestibule. Keep your front doors open, but keep the interior by the lobby doors locked. As he walks in, he's now captured because the front doors are going to lock, and now you have him isolated. That's what we're talking about. These are the types of scenarios and use cases that we're looking at as being one of the most exciting pieces of where BIM meets reality, not just as a graphic representation, but creating a cyber-physical relationship that the digital information on your iPhone is going to be locking doors, will be turning on lights, will be affecting your BMS and BAS systems like we've never thought before. The White House calls this the 4th generation of the Industrial Revolution, called the cyber-physical system age. How information technology, digital information is going to affect the built environment, we should be owning that as facility management people. So that's where I find a tremendous amount of excitement moving forward. This one particular image is of the HoloLens. BIM 2.0 is also helping the trades. We know a sub-trade in Southern California, in LA actually, called Martin Brothers. They're a drywall contractor. They actually have teams right now that go out without drawings, but use BIM inside of the mixed reality HoloLens to lay their track, to lay up the studs at 18 inches on center perfectly, to be able to then cut your drywall so that there's as close to zero waste as possible so that your taping job is easier and you can start moving on to the next project. Sounds all like fantasy, but if you go up to YouTube, take a look at Microsoft HoloLens, Martin Brothers, you will see a 27-year veteran. He's a foreman on one of their drywall teams that is fitting out by himself an entire room inside of the Wilshire Center, the tallest building west of the Mississippi in the United States that just topped off about 2 months ago. So they're doing tenant fit out right now without the use of drawings. The specs are then built into the BIM. That particular model then is projected into the HoloLens, and it is an augmented experience that actually then fits out the room for you so you know where the drywall goes. Amazing. So yeah, we're into this world where the architectural, engineering, construction methodologies are being challenged, which means that for facility managers, I think we're going to have a breakthrough where our relationship is going to be based on the data end of things. There's also some other good maintenance and preventive maintenance information, and that has to do with Cites out of Germany that work with elevators. There's a great example up on the Microsoft site about how Cites is using it for not having to carry around your A4 size or 8.5 by 11 O&M manuals. It's built into the HoloLens so that you can actually see in 3D the cab and the machinery and the mechanisms involved for that particular element, because it's trusted data, it's authenticated data, and you're viewing it in 3D. So that if there's a motor that needs tuning, that type of thing, you can actually see the entire system, use your finger in the air to actually then connect to the model, drill down to make it bigger scale-wise so that you can see how to fix it. When you're at the site, you can superimpose it onto the motor. And if you're unsure or need some help, Skype, because it's a Microsoft product, is built into HoloLens that then will project what you're looking at as a camera directly to that subject matter expert to help you through the process. So again, from a preventive maintenance way of going about it, through work order management, that type of thing, I think we're just starting to scratch the surface of where BIM 2.0 and the BIM data itself is going to just transform the ability for us to create a better built environment. This leads to the final part of of the session, based upon framework, based upon how you take innovation and make it into an ecosystem. Actually, the analogy I like to use is that innovations are the ingredients and you're the chef. Let's make a recipe, right? That works for you in your context. Part of that is to build in obsolescence, that knowing that you have a plug-and-play approach to many, many things because of the sheer vast amount of innovations that are coming down the pipeline. But, how does someone manage this? And then who manages it, right? Because let's take the piezoelectric system. If we have embedded in the ground itself, in the road, piezo energy generating pads, and you're harvesting energy, who's responsible for the maintenance of that road? Is it the DOT or is it the energy power company? So we're creating challenges as to governance and skill sets and how you're supposed to manage complete urban environments. This screenshot is on the left-hand side is of Atlanta. This was used as a persuasive argument for Mayor Reed to assist in convincing the city council and the general public that there was the need for the Mercedes-Benz Stadium because they already had a downtown stadium called the Georgia Dome, right? So he made that actually through an eloquent way of placing data captured from BIM for the most part, and then being able to take it out of the BIM environment and place it into other contexts, such as just the names of buildings. How about the energy usage? How about blah, 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 all those things. But when you start to congregate all those together, you could start to see interesting trends. So on the right-hand side, because this is all browser-based, by the way, it will work on any device that has a web browser, in this case an iPhone, what you're seeing on the right-hand side. What you're seeing there is the downtown DC Eco District. It's just east of the White House, all the way over to Union Station. And we've been able to collect data that's public and do dynamic color coding so that we start to see trends on things like energy usage, greenhouse gas emissions, maybe a program for the retrofit of single pane windows to start saving energy, and then looking at the costs. Again, being able to aggregate all of that data in an urban way, we can start to see the power of why people are excited about big data. Big data is big data. We've been dealing with big data since day one because we all manage buildings. What's interesting though now is the way that we're able to project that and report it, and that's the big breakthrough. This idea of being able to see information in 3 dimensions, being able then to take different disparate pieces of data and aggregate that so that you can start making some really informed decisions in a meaningful way, is starting now to open up the eyes of groups like the Emergency Response Systems of Kansas City, Missouri, Menlo Park, California, where they're using innovations in ways to help save lives. That's a great tool to actually put into a city operating system because that's a primary objective, right? Protect the general public. Dubai is looking at this right now to take into account things like autonomous vehicles. To get back to that point, they don't want to have multiple competing foundation technologies like algorithms of how these things should work, like who owns the rules of the road, right? If there's an emergency vehicle, if you're an autonomous vehicle, you're supposed to pull off to the side. I mean, just all those basic rules that we take for granted, they don't have to be programmed in, and someone or something has to manage that. This is why taking a global look through a gaming engine using a web browser is our best guess as to a 1.0 version of a city operating system. Now, the other cool thing about being in a browser is you're not talking about an application that sits on top of some big massive database that hackers can get into to take control of your city. I've watched way too many science fiction movies, right? So what we've done is actually taken the power of the internet and how HTTP works, in other words, web browsers, to actually get away with having and challenging the hackers to try and find where all that data is coming from. Because if you're opening up to multitudes of data and you're trusting not the database, but the individual piece of data inside of a database, and that trusted information can talk to another piece of trusted data, that's like a handshake. That handshake acts for the moment because it's being funneled into your version on your iPhone or on your desktop because you're in a browser. It's only as good as you have that browser open, right? So when you're actually saying, okay, I want to take a look right now what the energy usage is between this street, and this street because I'm in a meeting, I have to make a decision. You can take out your iPhone, boom, there it is. Once you close it, it all goes back to normal, meaning that it could be in 15, 20, or 20,000 different servers. So if you're only online for 10 minutes, I challenge any hacker to get in there and find all 20,000 points of origin and then try and find your browser. So built-in security is actually being thought of well ahead of how we're trying to display this stuff. This is why Dubai is really interested in this thing. It's what we're doing in Riyadh in Saudi Arabia right now. It's why we have 83 different cities from around the world that have standardized on this type of methodology. The other cool piece about this also from an innovation standpoint is this idea of blockchain, right, where you do have the transactions between people, places, and things. We're looking at this as being the foundation for a paperless process of transactions for leasing, for purchasing, things like title management, safety and security, where the blockchain data becomes as valuable as the brick and mortar itself. Let me say that again. When we go to blockchain as a industry, as a profession, and we all say, yes, when these two data points are connected, it's trusted. You are now creating a value for your individual building that is higher in most cases than the actual brick and mortar itself. Because now you can transact things out beyond the physical limitations of the building, right? So now all of a sudden this idea of leasing, micro leasing, almost like the Uberization of offices can be real. It can happen. It's now a matter of sheer will and use cases, and showing in a repetitive way how this is working. This is why, the blockchain 3D city operating system for Dubai will be installed and operating very, very well by the 2020 World Expo, and that's going to be one of the big pieces of showing how innovation can affect the urban environment. I'm actually going to pop through here, a couple of quick things here to get to the first responders stuff, because I want to close this out and see if there are any questions before the top of the hour. So I said before that when you have BIM as data and those data points can be trusted, we have opportunities to do things that are outside of our normal connection into how a city operates every day. Unfortunately, we have accidents. We have car accidents, we have fires, we have explosions, we have all sorts of stuff that happen every day because we're humans, and the only thing you can count on us is our irrationality, right? I mean, there's things happen, mistakes happen, accidents happen, but the emergency response to that is really where we think that smart cities are going to trump any sort of other efforts out there, because it's just better, faster, cheaper, and it works. One of these is actually working with the Kansas City Fire Department, Missouri, which we went through a pilot test with, dealing with geolocation of the actual firefighters themselves. We did a check-in, check-out process that allowed the Google Fiber that was laid. Kansas City, Missouri was the first city, actually Kansas City, Kansas, and Kansas City, Missouri were the first metro area to be outfitted with the Google gig fiber line that created the final mile, right, that last mile where they connected homes. They also connected things like, street lights and whatnot. But what it did was that if there's a fire at a certain home, we can now geofence around that home, around the perimeter of that property. How does that help? Well, what it does away with the clipboard and the pencil that an incident commander at a particular event uses to write down the names of the firefighters going into the scene and time and date stamp it. And then most importantly, time and date stamp when they come back out. The check-in, check-out procedure is something that is critical for saving firefighter lives so that they can save our lives, right? And right now, a pencil and a clipboard is probably the best practice around the world. So we said, well, if we have geofencing, it would be really interesting to put an RFID tag inside of the individual's name that's usually sewn into a firefighter's uniform. And that's how we did it. When a firefighter walked into the geofence, it would actually auto-populate into a digital format, usually on a thing like an iPad or a Samsung tablet, that type of thing, but a digital form. And then most importantly, it would automatically populate when they checked out. So that saves lives because you're not worried if it's snowing, if it's nighttime, where's Joe, blah, 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 blah. It's keeping an accurate accounting of the roster, which sounds really simple, but what a breakthrough, right? So how that works then is that it actually then uses BIM because we take from the building department the actual hard assets of what was submitted for permit. So we know where the staircase is, where the windows are, where the doors are, and how does that help? Well, it gives an assessment to the individual firefighters as to just another way of assessing the situation. God forbid that they have to go into a smoke-filled condition, they at least know where the hard assets are. right? So again, this is kind of the extension of what we're looking at from facility management, actually all the way from the beginning of either, a fit out, a retrofit, a renovation, or new construction from your consultants, where now you're caretaking it from operations and maintenance, which then extends out into the good for the general public, which is, safety, security, and those types of things. In Menlo Park, they're doing a very, very interesting thing. On June 2nd, we're hosting a symposium, a day-long symposium at Stanford University's Accelerator Labs up on Sand Hill Road in Menlo Park. The Menlo Park Fire Department has nests for their squadrons of drones. So they have these drones that sit up in these solar-powered nests until a call comes. So they're fully charged, they're ready to go. On the undercarriage of those drones, the closest drone then goes out because it knows that it's the closest one to that particular, like, let's say, house fire. Before the firefighters get there, what they're looking at in real time is eyes in the sky. We put a camera on there, and it's real time showing what the assessment is and what the situation is. The second thing we have is a heat sensor. That heat sensor can tell you exactly where the the hottest flame is, so that we can heat sensor and heat map where they should start fighting the fire. So a really, really interesting way also then of using UAVs and drones. But now, how do you actually create this thing? Because remember I mentioned before about autonomous vehicles, there's rules of the road. There's no rules of the sky right now. So we know that Amazon.com is actually testing in Menlo Park delivery for certain types of products off of Amazon.com to their customers. Now, what happens when there's a call and our emergency drone is going out, and at the same time there's a pilot delivery, a pilot test going on through Amazon.com? Who's the right of way? There's nothing official. There's no law. So what we're looking at right now is using the city operating system to manage that process, build in those rules so that even autonomously, they will then take care of the rules of the air, including the same thing as the rules of the road. So yeah, just really interesting times when it comes to this idea of the city operating system and how you guys are going to be involved with that. I'm going to close out here with some projects just to show you that this isn't just PowerPoints. It's not just about great ideas. It's about real implementations with real dollars associated with it. What you're looking at are the latest construction photographs I have of our project called the Kingdom Tower at Kingdom City, Saudi Arabia, which is in the northern suburbs of Jeddah. I believe we are renaming this the Jeddah Economic Tower now because there is a Kingdom Tower in Riyadh, and I think that there was some sort of, backlash as to calling this, two different towers the same name. So we're, as you can see here, we're about 62, 64 floors up out of the ground. This will be a 1 kilometer tall tower. You see our piling plan over to the left-hand side. We've been very pleased with the progress of this. Our responsibility is that we're the master planner for the city that surrounds this tower for all services, things like hospitals, police stations, fire stations, courts, all that type of stuff. And of course, housing for the workers. There will be 35,000 people, plus or minus, always in this tower at any time. So this is a true vertical city. The city that surrounds it here, as you can see, is not in a grid. Again, we're taking the idea of a totally autonomous vehicle environment. This is not going to be hybrid. The only motorized vehicle allowed is our developer. He's allowed to drive his Ferrari. His name's Prince Aloid. And you can actually see that there's one roadway right here as I move my mouse. That's called Ferrari Way. That leads to his tower, the world's tallest building. So if you do have a Ferrari, you're allowed to go there and join him. So I'm sure everyone on this call has a Ferrari. So yeah, this project is happening. 35% of all these buildings are being pre-manufactured and then shipped to Saudi Arabia from Beijing, China. So we're using a lot of 3D printing technologies, pre-panelization, but you can see that they don't look like that they belong in like rectangle heaven, which is the problem with most panelized systems today. They just look ugly. I don't care if it's cool and you're saving the environment. It's ugly. We're trying to make something beautiful. So by the use of 3D printing, through the use of adaptive technologies, lasers, that type of thing, we're able to create beautiful architecture. But 35% of this construction that will not be built in place. It will be just placed in place. So a remarkable project. One other one that we have going on is currently the world's largest proposed project. It's called Clara, standing for Consolidated Land and Rail Australia. It has a high-speed rail using maglev technology from Japan that will connect both Sydney, and Melbourne. The idea of that particular technology is that it does very well in short bursts, so it's not like Hyperloop, which does well in long bursts. We wanted the short burst because we have 8 stops, and each one of those stops are going to be 8 new smart cities to help alleviate the overburden population boom that both Sydney and Melbourne are having, which is bring down their quality of life. One last project also is actually again in Saudi Arabia, connecting both Riyadh, the capital, and the interior of the peninsula out to the coast Jeddah, where the Kingdom Tower is, or the Jeddah Economic Tower. This also uses the same technology using maglev, where we have 5 stops with 5 cities that don't exist right now. So this is where we're doing our greenfields. We're looking forward to a world where we can all start to have a greater say, especially the facility management people as the escrow agents of the built environment, so that we can create more organisms that can connect together and actually create a safer, a more secure, and a more beautiful built environment. So with that, I will hand this back to Josh, and thank you very much for your time.
Thank you, Paul. That was really fascinating. A lot of good information in this presentation. We are pretty much at time. We're slightly over, so I want to be respectful of everybody's time. So I'm going to try and wrap this up really quick. Can you go to the next slide, please? FMCC is always looking for volunteers to its STAG group. If you have any ideas for a webinar, white paper, etc., please contact Ricardo. His information is on the slide. He is the STAG chair, and I'm sure he would love to hear from you. Next slide. Okay, and don't forget, we do have some upcoming webinars still tomorrow. We look forward to having you on there. FMCC does always like to highlight the other councils and communities under the IFMA umbrella, and they're a great resource. Next slide, please. And Paul, again, thank you for a great, great webinar. And everyone, I want to thank you for attending for World FM Day, and I hope everyone has a great World FM Day. Take care. Bye-bye.